Hi all. Today we discuss section 22.9b. This is Gauss's forward interpolation formula. So this is the formula yp equal to y naught plus p times delta y minus 1 plus etc. So in order to remember this formula, we need to remember this diagram. From y naught, we use in the first term we will use y naught, and in the second term we will have this delta y minus 1 times this p. Then the next term we will have this term delta square y minus 1 along with this one, what we have exactly done in Gauss forward interpolation formula. So the only difference is the movement of this or the selection of these values from the table. And the next time we will have this delta cube y minus 2, and we have delta raised to 4y minus 2, and we will write the next term also. So that contains how will you write the next term? That's the idea here. So in order to write the next term, we will use this delta raised to 5 y minus 3. This is delta raised to 5 y minus 3 along with this factor, something divided by 5 factorial, that is p minus p plus 2. From this, starting from this, we have p here, then we had p plus 1 here, then p minus 1 here, then p plus 2 here, then you incorporate p minus 2. So p plus 2, p plus 1, p minus 1, then we have p minus 2. Okay, so we have 5 terms divided by 5 factorial times this plus etc. So in order to write the next term, we will use this factor delta raised to 6 of y minus 3. So in fact, this is the values from the backward difference table, forward difference table. So this is in fact this y minus 1 here. Okay, so we have the same thing here. We have delta, if this is y minus 1, then the next column we will have delta y minus 1 here. Okay, so in the next here we have delta y minus 2 in the table, and here we have delta square y minus 2. So we are neglecting these terms from the table, so we choose only this much values to evaluate this. Okay, so using this we will discuss an example illustrating this. This is the example. Interpolate by means of Gauss backward formula, backward. The sales of a concern for the year 1976. Given that these are the values, in 1940 we have 17. These are the rupees in lakhs, 17 lakhs, 20 lakhs, 27 lakhs, etc. So using these values, we need to interpolate the sales for the year 1976. Okay, so first of all, you consider the interval of differencing, that is 10 here, 1940, 50, 60, 70, 80. So they are all at equal intervals, that is the length of the interval is 10, and using this fact we define p is equal to x minus 1970 divided by 10. X minus x naught, this is first we fix x naught. This x naught is equal to 1970. This is because of this fact we need to interpolate the value value at 1976, that comes somewhere here. So we set x naught as the x value just before the 1976, so that is 1970. So using this fact we define p is equal to x minus 1970 divided by 10. Okay, so in fact this we set this is our p, then we construct the table. This is the table. These are the x values. Now we evaluate p value for each of these x's. So that is 1940 minus 1970 divided by 10 and so on. So if you take this 1970, you have 0 here, and here we have -1 and -2, -3 here, and here we have 1, and this is 2, and the corresponding y values, that is 17, 20, 27, 32, 36 and 38. So these are the y values. Now you evaluate delta yp. So these are again the forward difference. We know that if you discuss the formula, it contains the forward differences, delta. So we use the same table. Even though this is backward interpolation formula, we use the same forward table, but we take the differences in backward position. That's the name that justifies the name backward. So here we have 3, that is 20 minus 17. Here we have 7. This is our we write it as 3 here, and this is our 7, and this is our 5. 32 minus 27, and 36 minus 32 is 4, and 38 minus 36 is 2. So this is our delta y minus 3. This is our delta y minus 2. This is our delta y minus 1. This is our delta y naught, and this is our delta y1. So these are the values. Now you have the difference of these two, then we will get the second order. So this is 4 and 5 minus 7, that is -2. This is 4 minus 5, that is -1, again -2. So these are the values. Delta square of y minus 3. This is delta square of y minus 2. This is delta square of y minus 1, and this is delta square of y naught. So these are the values. Okay, now you have third order. So here we have 4 minus -2, that is 6 here, and we have 6 here, and the difference between these two, -1 minus of -2. So we have 1 here, and -2 minus of -1, so that is -1. So we have this is our delta cube y minus 3, and this is delta cube y minus 2, this is delta cube y minus 1. Okay, now take the difference, fourth order difference, that this will be 1 minus 6, that is this is our -6, that is -2 minus 4, that is -6, 1 minus 1. Now take the difference, 1 minus of -6, so that will be 7, and -1 minus 1, that is -2, and this will be delta raised to 4 y minus 3. This is delta raised to 4 y minus 2. Okay, now take the difference of these two, that is -2 minus 7, that is -9. This is delta raised to 5 y minus 3. So these are the values. Now we use before we go into use the formula, we denote those values that we really wanted to get the formula. So we need in this formula, in fact I will write the formula again here. This is our formula. So first we need y naught. So this is our y naught. Y naught is 32, sorry, x naught is 1970, then this y naught is 32. So this is our y naught. So first we want this number 32. So this is our first number required for the formula, and p times delta y minus 1. We move backward, so that's why this is called backward interpolation. And we want to we have selected y naught and this delta y minus 1. Now we choose delta square y minus 1, so that come this way, delta square y minus 1. So first we move on to this and then come to this point and again come to this backward. So we have this number here, delta square y minus 1 here, and then next time will be delta q y minus 2, and then we, after going to this, we come to this number, and that is written here, delta raised to 4y minus 2, and finally we have this delta raised to 5y minus 3. So these are the values. So this is the way we choose the values to evaluate this formula. So now using these values we evaluate this expression. Okay, so we already in order to evaluate the y value at x equal to 1976, we set x equal to 1976. So using this x we evaluate p. In order to evaluate this formula, where p will be 1976, that is x minus 1970 divided by 10. So this is our p. So p is nothing but 0.6 and x equal to this one. Okay, now you apply the formula. Yp will be, this is our y value at x equal to 1976, that is equal to y naught. Y naught is this one, 32. So 32 plus, we have p times this, that means p times this one. So p is 0.6, that times this number 5, plus the third term will be p plus 1, that is 0.6 plus 1 times p, that is 0.6 divided by factorial 2 times this times delta square y minus 1, that is this number, delta square y minus 1, that is minus 1. Okay, now we have p plus 1 into p minus 1, 0.6 minus 1 divided by factorial 3 times this delta q y minus 2, that is delta q y minus 2 is this one, that is 1 again, so you multiply it with 1. Now the fifth terms, okay, the second last term will be p plus 2, that is 0.6 plus 2 into 0.6 plus 1 into 0.6 into 0.6 minus 1 divided by for factorial, so this is in fact for factorial, times this value, delta raised to 4 y minus 2, that is minus 2, so this times minus 2. Okay, plus the last term, that is 0.6 plus 2, 0.6 plus 1, 0.6 minus 1, sorry, 0.6, then 0.6 minus 1, 0.6 minus 1, 0.6 minus 2 divided by 5 factorial times delta raised to 5 y minus 3, so that is this number, that is minus 9. Okay, so when you evaluate this expression using a calculator, you will get I really don't want to evaluate all this in this video. So you evaluate these numbers, then you will get 30.114368. so this is the y value at x equal to 1976. So we write the sales in the year of the sales in the year 1976 is 30.114368 lakhs. Suppose all the sales are given in lakhs, so this is the answer for the exam. Okay, so this is the illustration of Gauss backward interpolation formula. We discuss 22.9 again. First we discuss Stirling formula. So this is the Stirling formula. To remember this formula, how you need to remember this one. Here we have y naught, here we have delta y minus 1, here we have delta y naught, and on the center line we have delta square y minus 1, and here we can see delta cube y minus 2. Here we have delta cube y minus 1, and here we have delta raised to 4 y minus 2. Okay, So this is the way we choose the values from the table. First we choose y0, then we take the average of these two numbers. Okay, so that is 1 by 2 times delta y0 plus delta y minus 1. Now we again come to this. Okay, so that is delta square x square by 2 factorial times. So please remember this. You need to remember these numbers, these coefficients, otherwise you cannot apply this formula. So please remember this. This is enough. This much term is enough, because we are doing problems up to this stage with the accuracy of these fourth order difference. So again we have averages of these two numbers, and then come to this. Okay, so this is the way we choose the coefficient from the table. In fact, this is the table what we have written. This, suppose this is y0, here minus 1, y minus 2, y1, y2, etc. Then here we take first in the second column we have delta y minus 2, this is delta y minus 1, delta y0, delta y1. Okay, then this will be delta square y minus 2, this is delta square y1, delta square this y minus 1, this is delta square y minus 1, this is delta square y0. From this you can get delta q y minus 2, this is delta q y minus 1, and finally we have delta raised to 4 y minus 2. So this is the table. So we have written what this diagram means, that we from this table we first choose this value, then take the averages of these two numbers, then take this value, and take the averages of these two numbers, then take this. This is what we have written here or drawing here. This is the way to remember the terms in this formula along with these coefficients. So please try to remember this formula, otherwise you cannot perform the problem. So we describe it using or illustrate this with an example. So we start with an example. Given that the values of theta and the values of tan theta, we are given some angles: 0 degree, 5 degree, 10 degree, 15 degree, 20, 25, 30. So the corresponding tan values are 0. Here we have 0.0875. This is 0.1763. This is 0.2679. This is 0.364. This is 0.4663. Finally we have 0.5774. Okay, so how will you find this? This value of, or the question is using Stirling formula, show that tan 60, or find the value of tan 60, tan 16 degree. So this is the question. Now in order to evaluate tan 16, we set x. Okay, so first we need to set x or p, whatever be this number, so we need to set that. So we write it as x equal to theta minus 15 by 5, because this interval is of length 5, so theta minus 15 by 5 is the x value. Okay, so this theta, we have theta is equal to, we need to find tan 16, so x value at theta is equal to 16 is 16 minus 15 divided by 5, that is equal to 1 by 5 is equal to 0.2. Okay, now you evaluate yx. Okay, what is yx? Yx is perform this formula, that is y0. Y0 is this one. Okay, so before that we need to set the table. So I'll write the table here. Okay, so please perform. I will give the values of table using the values of theta and tan theta. So these are the values. So I take 0, 5, 10, 15, 20, 25 and 30. So these are the values. So the corresponding x values are, these are theta, and corresponding x values are, for these values we set x equal to, we need to find out the 16 is somewhere here. So we set x naught is theta naught is equal to 15. So the x values in the previous problems we denoted this number as p. So the corresponding x value using this formula is 0 here. This is -1, -2, -3, and 1, 2, 3. Okay, now take the del y. Okay, so that is the difference between first we'll write the y values. Y values are 0.0875, 0.1763. so this is the second value. First value is 0.0875 and 0.1763, 0.2679, 0.3640, 0.4663, and we missed one thing. Okay, 1, 2, 3, 4, 5, 6, 7. We have 7 values. That is, if the first value is 0. Okay, so we write, these are the values. First value is 0, then we have this much values. These are the y value, and take delta y and delta square y and delta cube y and delta raised to 4y. So perform all this finding forward difference table. So take the difference between these two first, then write here, and difference here, difference here. So you complete this and choose the values starting from y naught. Okay, first you choose y naught. This is our y naught, since x naught is 15. Then choose these two values and take the averages of these two and multiply it with x, and then for the next value we choose this value here and multiply it with x square by 2 factorial and so on, and perform this. You can get the value of yx, that is tan 16 degree is equal to 0.286, okay, 671. So this is the value of tan 16 using the Stirling formula. Okay, next we discuss Bessel's formula. This is the Bessel's formula. So yx equal to 1 by 2, we starting with y1 plus y naught, half of that, half of y1 plus y naught, plus x minus half into delta y naught, plus x into x minus 1 divided by 2 factorial into half of the average of these two numbers, and so on. So how will you remember this? So we start with this, remember the starting point, half of these two numbers. So we take these two numbers first, take the average of these two numbers. Okay, then come to this number, and the second term we have delta y naught, that is because of this. Come to the center line, and again we take the difference average of these two numbers, delta square y minus 1 plus delta square y naught, and take the average of these two, and again come to delta cube y minus 1. Then you take the other two, delta raised to 4 y minus 2 and delta raised to 4, that comes here, delta raised to 4 y minus 1. So take the average of these two. Okay, so this is the way we use the values from the tables to evaluate Bessel's formula. So please try to remember this formula along with the coefficients. So you can easily remember this thing, but it is not so easy to remember all these coefficients. The first coefficient we have only this term, and the second term we have this coefficient x minus half and x into x minus 1 divided by 2 factorial, and so on. Okay, in the textbook you are given a illustrative example, so please try to work it out. That is a worked out example, so please try to work it out with the table. That is exactly same as the previous problems. This is nothing, the only thing is to construct the forward difference table. So here we use the forward difference tables to evaluate all these central difference central interpolation formula. Okay, so next class we will discuss other one central difference interpolations, say Laplace Everett formula and divide difference formula, Newton's divide difference formula. So these are two remaining central interpolation formulas. Then we can conclude, after that we can conclude section 22.9. Okay, thank you.